Okay. You're able to see my screen?
Yes, sir.
Okay. Last class, where did we stop? Unit 2. I guess we completed up to, let's see. We did one problem here, right? With the LCG and
Yes,
LCG.
sir. Yes, sir. This one.
Yeah. Okay. Okay. Fine. Fine. Okay then. Okay. So if you want to refresh our last class, what we did, because we'll be continuing with same type of problems with little, changes to it. Because these problems, we had initial displacement was given to us and LCG was given to us. Then we had final some cargo operations being carried out, loadings and dischargings. So what we did, we took the moments table and found out the final displacement and final LCG. Then with the displacement, we entered the hydrostatic tables to find out all these datas so that we can apply it in the formula and get the trim. Then we got the forward and aft corrections. Then finally, we got the final graphs. Okay. So now, till now in this problem, we were doing loading and discharging in the moments table. Now here we'll be doing a slight variation, which is shifting. We'll be talking about shifting of weights. Okay. A vessel floating in salt water is initially displacing 12523 tons. LCG is given to you. Okay. LBP is also given to you. Okay. Now here 50 tons of bunkers are transferred by shifted from the forward bunker tank. Okay. From the forward bunker tank is situated 131 meters FOAP to an aft bunker tank situated at 25 meters FOAP. So what are we going to do is we are going to shift 50 tons of bunkers from the forward tank to the aft tank. And both the tanks, the position is being given to us. So calculate using the hydrostatic particulars, the final drafts forward and aft. Okay, here we are not doing any loading operations or discharging operations. The vessel has an initial displacement and we are going to just shift 50 tons of bunkers from forward to aft. That's all. So with that, how to find out the final drafts? Now, while shifting of cargo, how do we approach a problem is where a vessel shifts weights, then it is best calculated by first discharging the weight from its original position. So in this example, weight is transferred from the forward bunker tank at 131 meters. So what we will do during the moments table, we will first discharge the 50 tons bunker at this position. We will first discharge from the initial position, original position, and then loading at its new position. Then we will load back at this position, 25 meters FOAP. So this is how we will approach the shifting of weights problem. Okay, so here again we will take the ship's initial displacement 12523, LCG is given. Okay, so we will get the moments. So as I said, first we will discharge the cargo. Discharge at this point 131 LCG. Discharge from 131. So I will write this in the discharge moments. Next, I will load the cargo 50 tons at LCG 25. Okay, at LCG 25. So I've done nothing else. I've discharged from that point, initial point, and then again loaded at the final point. So here, first movement will be in the discharge section. The second movement will be in the loaded section. So finally, I get my displacement to be 12523. So if you see here, the displacement is not going to change because my initial also is the same, final also is the same, because we are not loading or discharging a cargo. We are just shifting of weights. So your displacement of the vessel doesn't change. It remains the same. So then you get the moments here. So now to get the final LCG of the ship, moments by weight will give you the final LCG of the ship. So now I got my final displacement and LCG of the ships. Okay. Now why are we doing this in shifting of weights? In previous problem, shifting of weights, we used to find the D distance and all those things. Here we are taking this approach because displacement we know that it is not going to change. But whereas we need to find out the final LCG. So from 131 to 25, when these changes occurs, we need to find out the LCG because the moments will change. So due to that factor, we are taking the approach of first discharging first and loading second, so that we will be able to find out the moments correctly. And with that, we'll be able to find out the final LCG of the vessel. So that is why we have taken the approach of discharging and loading. So understood that concept of discharging and loading back again when shifting of weights are involved. Guys, all of you understood?
Yes, sir.
Yes, sir.
Fine. I want you guys to be little interactive. Okay, then otherwise it becomes very tough of me. Okay. So now then what we do, like previous problems, I guess somebody's mic is on, man. So we will enter the hydrostatic tables with the displacement. I have the displacement. For this 1, 2, 5, 2, 3, I go to the hydrostatic tables. For 1, 2, 5, 2, 3, where will it come? It is somewhere here. For 1, 2, 5, 2, 3, my draft is 6.1. My MCTC value will be 171.1, LCB and LCF. Now all these four values I will find out. Now after this, it becomes a similar problem as we did the last one. The only change here is the shifting one, that's all. So all these four problems remain, all these four values you find out, and then application is the same. You apply in the trim formula. Whatever values you have found out, you will get the trim to be 139.3 centimeters. Okay. Now, like as previous problem, if you would have discussed, how do you get it, by stern or by head? How do you know that my trim is by stern or by head?
Uh,
With
so by
respect to,
movements, we can get it by directly.
With the moments directly? No, with LCG and LCB, I have told you, right? How do you get it?
with respect to G and B.
Yeah, with respect to G and B. So what I have told you with respect to G and B?
B is fixed, sir. If the
Yeah.
G is aft, so we take it as stern, sir.
Okay.
So in case of G is forward, we take it as head.
Okay. Very good. Okay. So that is what I want you to remember. You need to plot the position. So here also, always for all problems, we have to draw this sketch. So we know the LCG of my vessel is 68.477. So I plot from aft perpendicular to position G is 68.477. Now I have already found out my LCB. Now you see LCB is more, 70.38. So it will come somewhere here. So now when I plot this, I see my G is aft of B. So it will be a stern trim. Okay, so that is the reason I mark it here as my trim to be by stern. Okay, so then the procedure remains the same for the previous problem what we did. We calculate the forward correction and the aft correction. So since it's by trim, we will add the forward, we will add in the aft section and subtract in the forward section. I'm not going very deep into each and every step because the same process we did it in the previous problem also. Okay, so the only change here is shifting of weights. So I emphasized mostly on the shifting of weights. And I've already shared this PPT to the CC's group. Okay, so all of you, just get it from your CC. Okay, the PPT of Unit 2. Okay.
Yes, sir.
Fine. Understood on this problem, shifting of weights?
Yes, sir. Understood.
Okay. Fine. Now what we will do, we will go to the next problem, where in the first problem, yesterday means last class, what we saw was loading and discharging. Like this was the first problem which we started with LCG and LCB. So here, loading and discharging we did. Now today we discussed shifting of weights. Okay. So now the third problem what we will discuss is we will combine both these two. we will combine loading, discharging, and also shifting. We will combine these two problems, these two things, and work out this problem. Okay. A vessel LBP 141.2 meters is floating in salt water at an even keel draft of 2.77. Okay, it is floating at a draft of 2.77. Now, as soon as you read this first line, what is the difference between the last problems you see here?
So there was a displacement of ship was given. Now here the displacement of ship is not given.
Okay, very good, excellent. In previous two problems, displacement and LCG was given to us. So initial displacement and LCG was given to us. But here, instead of giving displacement and LCG initial, they've given you the draft, initial draft, which is an even keel draft. Okay, so with this even keel draft, which is actually called as true mean draft, you can take it as true mean draft, right?
Yes, sir.
Yes.
Okay, so with this draft, instead of going to displacement, with the draft, I can find out my displacement and all other data. Can I do that?
Yes, sir.
Yeah, so just remember, whenever you want to enter into hydrostatic tables, you need two datas. One, it should be a displacement, or it should be a true mean draft, or which is also called as an even keel draft. So here there is a small change. Instead of giving displacement, we have been given drafts. Now using hydrostatic particulars, calculate the final drafts forward and aft. Okay, so now what happens now? Since we don't have the initial data, we just have the initial true mean draft 2.77, but we don't have the initial displacement of the ship, initial LCG of the ship. Because once we know these two only, we can do the moments table, because we need to know the initial displacement, right? Then only we can do a moments table. Because for doing a moments table, we need to start off with the displacement of the ship, right?
Yes, sir.
So here also, we don't have that. So we need to gather the initial data. So to gather the initial data with 2.77 draft, I will go into the hydrostatic tables and find out some values. Now you see this interpolation thing, which I told you in the previous things, you can combine 3-4 interpolations into one thing. Because for 2.7 and 2.8, you're going to find out two values. You need to find out displacement and you need to find out LCB also. So you see, instead of writing two sketches in one sketch itself, you can do this, because A and B is going to remain the same value. Only C value changes. So for displacement for 2.7, it is 5164 and 2.80 is 5371. LCB again, you can note down like this. So it becomes easy here. Directly you have to find out C value here and C value here. You don't have to put on two sketches. So A and B remains the same value here. So it becomes easier for you to interpolate. So what I do, displacement will be the same, 5164 plus A by B into C. So this A by B will remain the same, you can see here. Only your C part is going to change. So my displacement is 5308 and LCB is 71.612. Now why did I find LCB of the ship? Because our final intention is to find LCG. But when the ship is at even keel, can I say that my LCB is equal to LCG?
Yes, sir.
Yeah.
Both
So
will be in the same.
yeah, both will be in the same place. So my LCB will be equal to LCG, and the vessel is already on even keel. So what I did, from the hydrostatic tables, I found out LCB, and since my vessel is on even keel, I can say that my LCB is equal to LCG. So my LCG value also will be 71.612. Okay. So now what happens? Now with my initial TMD draft, I got my initial value, initial displacement, initial LCG. Okay. Now after this, what I do, once I get my initial displacement and LCG,
Doing moments method to calculate LCG.
exactly. So now after this, what happens? It remains the same problem as we did in previous, because in previous problems, we started off with displacement and LCG. Here, a little step before calculation had to be done. Only this part is the extra part which we have done. So once you find out this displacement and LCG, then everything remains the same as we did in the previous problems. Fine. So we will start off with the ship's displacement. LCG we found out. So that will be in the loaded moments. Now these three cargoes are loaded. You can see here, we loaded these three cargoes at various LCG positions. And 529 and 596 were discharged. These two cargoes were discharged. So now the last part, shifting 260 tons from LCG 110 meters to LCG 15 meters FOAP. So now for shifting, what did we discuss? How do we
First we
do
will
it?
discharge, and then first again we will load.
Yeah, exactly. So first we will discharge. We will discharge from which position?
Forward to the aft.
No, just look at the question, man. At this here, forward and aft is not given, right? The value is given at LCG 110.
LCG 110
Yeah. So
to LCG 15
yeah.
meter.
Yeah. Okay. Good. So we will discharge from this position 110 meters LCG, and we will load back at 15 meters. So we'll be doing the same thing in the moments table. What I will do first, I will discharge 260 tons at LCG 110 and write it in the discharge column, discharge moments column. Then what I will do, I will again load back 260 tons, LCG 15, and I will write it in the moments, loaded moments column. Okay. So with this, I get my final displacement. And I get my moments here. So my final LCG will be moments about the aft perpendicular divided by weight. So which will give me 69.474. So now what happened with I got my initial displacement and LCG. With that, I took the moments table and found out my final displacement and final LCG. I got the next two values. Now with these two values, what can I do? What did we do in the previous problems? The next step.
So we can calculate trim.
Yeah, good. Exactly. So after this, we will be calculating the trim of the vessel. So trim of the vessel, what is the formula? W into LCB difference LCG by MCTC. Okay. But for calculating the trim of the vessel, do we have all these datas? Displacement, do we have?
Yes, sir.
Yes, sir.
Okay. LCB, we have LCB, LCG, and MCTC.
No, sir.
Yes, sir.
We don't have, because we found out displacement, final displacement, and LCG we found out, but we don't have other datas. Like we don't have LCB data, we don't have final MCTC data, but we have our final displacement, right? The final displacement, I can again go into the hydrostatic tables, find out my true mean draft. Because what is the question asked? Question is asked, initial draft is at 2.77 even keel. Calculate the final drafts. So I know my initial draft only. So what did I do with my initial draft? I got my initial displacement and initial LCG. With this, I worked out, because after that only we did loading, discharging, and shifting operations. Then finally I got my final displacement and LCG. But still I need to get my final drafts, right? Because you have done some operations, right? Your draft is going to change. You accept that?
Yes, sir.
Yeah. So with the final displacement, again I go to the hydrostatic tables, find out TMD, MCTC, LCB, and LCF, because I require all these to again go further with the problem. So now here you see the method which we interpolation what we saw, it becomes easier here, because your A and B value remains the same, only your C changes. So you can write in this fashion itself, one below the other. So you have to just write C values here. So this minimizes lot of your time. Instead of drawing 5 sketches in one sketch itself, you can finish off everything. So even keel draft will be 5.043 MCTC. All these values can be found out. This I have found out from the hydrostatic tables. Okay, so I have interpolated and got these values. Now you understand, like, this method. Do you think this method is easy?
Yes, sir.
Yeah. So since because A and B remains the same, in all you see, this A by B remains the same. In all these things, only your C value is going to change. So once you find out A and B values, C you just find out and immediately you can keep writing down the values. It will save actually a considerable amount of time. Fine. So now with my final displacement, I have got all these values. So then I can apply it in my trim, because my intention is to find the final trim of the vessel, final trim and the final drafts of the vessel. So now W I know, LCB I know, LCG I know, and MCTC I know. So my trim will be 82.97 centimeters. Now whether it is by stern or by head, again I will plot the sketch. What is my LCG value? 69.47. So I will mark 69.47 G value. But whereas my LCB value is 70.773, which is actually more. So my B will come more here. So since G is aft of B, it will be a stern trim. Okay, so this will be by stern. So rest all remains the same. Your forward correction and aft correction. And then you apply it to the even keel draft 5.043, which we found out here. So remember, this was your final draft. Your initial draft was 2.7. But once after loading and discharging operations and shifting operations completed, your final draft was 5.043 even keel draft. So then I apply these corrections to get my final drafts forward and aft. Okay guys, understood? Any doubts in this problem?
No, sir.
Fine. See, as soon as you read the problem, first try to assess the problem. What data is given to you? Okay, so don't straight away jump into start solving the problem. As soon as you read this, the first line itself, you should start analyzing it. What data is given to you here? Instead of displacement and LCG, a draft is given to you, which is the initial condition. But for initial condition, I need displacement and LCG, which I don't know. So what I do from these drafts, I go to tables, find out the initial value. Then what I do after this, once I got my initial data, some operations have been carried out. So what I will do all this moments table and find out my final displacement and final LCG. So now once I got this, I need to apply it in the trim formula, which is this formula. Now to apply it into the trim formula, I don't have all the datas. I have only displacement, whereas all these other datas I don't have. LCB and MCTC, and I require LCF also. So these three datas I don't have. So that is why what I do, I again with the displacement, final displacement, I go to the hydrostatic tables, find out all these values. Okay, so with that I get my final drafts. Okay. So remember, with LCG and LCB, we have done one loading and discharging problems, one shifting problem. Then we have done one problem with loading, discharging, and shifting, all three combined. Okay, fine. I hope all of you are able to follow it.
Yes, sir.
Okay. Fine. Now what happens till now, what we have been discussing is initial condition was given to us. Initial condition means displacement was given to us and LCG was given to us. Okay, and we know that if it was draft was given, it was an even keel draft. But here now what we will be seeing, the next new one is to calculate displacement and LCG from observed drafts. From observed draft means now in this condition, initial forward and aft draft will be given, not even keel draft like this. Even keel draft we already saw. Now what we'll be seeing is not even keel draft. We'll be seeing problem with forward and aft draft as given, initial forward and aft drafts. So when initial forward and aft drafts are given, there must be a trim. So in that case, your LCG and LCB will be different, right? It won't be in the same position. You agree on that?
Yes, sir.
Fine. So that is when the we have to have a different approach, because till now we have been given direct data. Now direct data is not given, trim is given to us or draft is given to us. So from that, how to find out the final draft? So if you see, if the ship is initially trimmed, then the position of the LCB and LCG must be different to start with, because you don't know exactly where the position is, you just know the trim of the vessel. So now what, since we have an initial drafts, since we have drafts, from drafts you can start the approach by calculating the true mean draft and then going ahead with the problem. Because what I have told you, if you want to enter the hydrostatic tables, you need two datas. One is displacement or TMD. Now in this case, initial forward and aft draft is given, means I can find out TMD, right? Can I find out my TMD?
Yes, sir.
Yeah. So with the TMD, I can go ahead with the problem. Now one more data, what I know is trim of the vessel, because initial forward and aft draft is given, so I can know the trim of the vessel. So I know this trim. So what I will do, I will find out other values and try to get the value of LCG. Okay. So, but before going into the problem, let's have some basics cleared on this with respect to LCG and LCB positions. That is, when the vessel is at even keel, we know that LCG and LCB will be at the same position. So this will be equal to, LCB will be equal to LCG. So therefore the trim will be 0. But whereas when it is trimmed by stern, when it's trimmed by stern, what is the condition actually? Where is G, where is B?
G will be aft of the B.
Yeah, G will be aft of B. So this is the condition when the vessel is trimmed by stern, which we know that. So what happens? We can also say that if vessel is trimmed by stern, LCB is greater than LCG. Because since G is aft, we can also say is LCB is greater. The value of LCB is greater. So we can write this formula as LCB minus LCG, because LCB value is greater when the vessel is at stern trim. I can write the formula to be LCB minus LCG by MCTC. Now, why I am writing this formula as like this? Because you told me that initially LCG, it was LCG difference LCB, right? The formula. But why are you writing again minus? Because why are we doing this is, we want to find a positive value here. So when I have a stern trim, I consider that my LCB value is more. So I write LCB minus LCG so that I get a positive value here. Okay, just for the sake of our understanding. In the same way, when it is trimmed by head, I know my LCG is greater, right? I need to see which is the greater value. So when it is by head, I write it as LCG minus LCB. Okay, so that I get a positive value here. Okay, so understood by stern and by head why I am doing this?
Yes, sir.
Okay. Fine. So now what we will do, we will solve a problem where initial drafts are given and we will try to find out the final drafts. Now let's see how to approach on that. Now this is actually the summary which I've given, how to approach the problem. Once you finish the problem, you can go through the summary, which will become easy for you. So let's go into the problem. Okay. Now you see vessel A has draft forward 4.60 and aft 6.40. In salt water, LBP is given to us. Now find the drafts after loading 900 tons at LCG 100 meters and 700 tons at LCG 50 meters FOAP. So now if you see, the problem is hardly anything. It is just 2-line problem. But just see how much of calculation it involves. This is the first slide. This is the second. This is the third. This is the fourth. This is the fifth. And this is the sixth. So almost it takes 6 slides to solve this problem. Okay. So don't get carried away with that it is just a 2-line problem. Okay. So now here, the change what we see here is, what is the change we see here with respect to other problems which we have discussed? All of you, what is the change we see here in the problem?
So the initial displacement is not given.
Yeah, initial displacement and LCG is not given to us, but initial drafts are given to us.
Yes, sir.
So now what we do with the initial drafts, I can find out my TMD draft to go into the, because now I have to calculate my initial displacement, initial LCG. I have to find out those values. Then only I can go into moments table, right?
Yes, sir.
So for that, first we will work on finding out the initial condition of the vessel, initial draft. So for that, I need to find out, the first part is I need to find out the initial TMD of the vessel, true mean draft of the vessel. Now what is the TMD formula? True mean draft formula?
So draft aft minus that formula is there.
Yeah, draft aft minus DA minus DF by LBP into LCF. So this is the formula for finding out TMD. But here LCF is not given to us. Now how do we find LCF when it is not given to us in the problem?
We calculate the AMD.
Yeah, exactly. We will calculate the AMD, then find out the LCF. So what we do, we will first start off calculating the AMD, arithmetic mean draft, which is the draft forward plus aft by 2. So I will get my arithmetic mean draft as 5.50. So then what I do, I go to my hydrostatic tables. So for 5.50, I see what is my LCF, 68.80. Okay, so I go to my, for 5.50, I got the LCF to be 68.80. Now I can also calculate the trim, because my initial drafts are given to me. So I can know what is the trim of my ship, initial trim. All this what we are doing is the initial condition. So I know my initial trim. Now I apply the TMD formula, draft aft, all this LCF I found out. So finally I get my TMD draft to be 5.499. So this is my initial draft. Now with this initial draft, can I find out under all other initial conditions like displacement, MCTC and LCB, all those things?
Yes, sir.
Yeah, with this TMD
Yes.
draft, again I can go to hydrostatic tables and find out my initial condition. So let's go to again hydrostatic tables. With TMD draft, I get displacement, MCTC and LCB. You see, again this interpolation becomes easy because all three values you can find it at one shot. So I found out displacement, MCTC, excuse me, sorry, and LCB values. So remember, now we are still in the initial condition. We are just still finding out the initial data of the vessel. So once I get displacement, everything, I still have to find out the initial LCG. Right, till now I got only the displacement of the ship, initial displacement of the ship. Now why do I require initial LCG?
Fine.
Sorry?
To find out where is the position of G.
Yeah, but with that, what is the use of it?
So we can identify that there's a vessel is streamed by stern or.
Yes, that is one thing. But to start off with the moment stable, you need the initial displacement and initial LCG, right?
Yes, sir. Yes.
You remember, start off any moment stable, I require my initial condition. I require my initial displacement and LCG. With that only, I can find out the final displacement and LCG. So that is what we are doing here. What we are doing is we are finding out the initial condition. Initial displacement I got, but I did not get LCG, initial LCG. So for that only, I require all these data, because what I will do with the initial condition, I will apply it in the formula. Trim is W into LCB difference LCG by MCTC. I know the trim of my vessel. What is it? We calculated the trim of vessel, right? One.
Yes, sir.
Guys, you can hear me?
Yes, sir.
Yes, sir.
I think in between there was some network problem, right?
Might be so.
Yeah, okay, fine. I think and recording is still going on, right? Okay, fine. Okay. So in this, I know the trim of the vessel. I know all these datas. Only the data which I don't know is LCG. You see LCB data I know. I don't know the value of LCG. So I apply it in the formula. All other datas are known to me except LCG. So I rearrange and get the value of LCG to be 67.96. See, now that the information for the initial condition is known, the final condition can be calculated by taking moments. So remember, just till now we have been calculating only the initial condition. Just to calculate the initial displacement and LCG, we have to do all this. Okay, we calculated AMD, then TMD. With that, we got all these values. Then we applied it in this formula. We got the final LCG. So till now we've got the initial values. Now, once I got my initial displacement and LCG, then what I do? Guys, then what I do after I got my initial displacement and LCG.
Moments.
Yeah. Moment stable. Now, can you say that now once we have come to the initial stage, this is similar to the last problem, where displacement and
LCG.
you see displacement and LCG is given. So that is what in the first section it was given directly, but now we have come to this section, this point. Now from this point it remains the same. Whatever calculation we do, you know already how to go ahead with this. So till now we have reached up to this stage. Earlier problems it was given to you directly, so it was very easy for you. But instead of giving it directly, they have given you the initial drafts. So with the initial drafts, now we found out the initial condition of the ship. So once I find out my initial condition, displacement and LCG, I know my certain cargo operations have been carried out. Now what was done? Loading 900 tons and 700 tons at 100 meters and 50 meters. Now, what is it?
Yes, sir.
Okay. So now what I will do, I will go to the moments table to calculate final LCG and displacement by taking the moments table. Now, initial displacement I know 67.96 LCG. I get my loaded moments. 900 tons is loaded, 100 LCG, and this will be my loaded moments. 700 tons is again loaded. I will get my loaded moments. So finally, I get the final displacement of the ship and moments. So to get the final LCG of the ship, final moments by weights will give me my final LCG of the ship, 69.233. Okay, so now I got my final LCG of the ship and the final displacement. Okay, now with these two values, how do I go to the next problem or next thing? After this, what I do?
So by graph, we can get all the, using hydrostatic tables, we can get all the details.
Yeah, now it is similar to the last problem because to find out trim, I need all this data, which I don't have. Right, displacement I have, but other things I don't have, like LCB and MCTC. So again, I do the same thing. Now I got my final displacement of the vessel. With this displacement, I am going to find out other final parameters. So what I do, I again go to the hydrostatic tables. So remember, you see in the same problem, we are doing almost 8 to 10 interpolations. So that is why I told you to, go ahead with this so that it will become easy for you. So now with this final displacement again, I find out all these data. I can find out TMD, MCTC, LCB, and LCF because I require all this data to get my final drafts. So you see here, A and B remains the same, whereas the value of C changes. So again, and by entering the hydrostatic tables, because my initial draft is different, but now after loading, my draft will change. So that is why again I have to find out my true TMD draft, MCTC, LCB, and LCF. Fine. So once after calculating all this data, I apply it in the trim. Apply it in the trim and get 82.4 centimeters by stern. Now why by stern? We have to again see LCG is 69.233, which I got it from here. LCB is 70.346. Okay. So since G is after V, my trim will be by stern. Okay. So I will get my trim by stern. Rest all remains the same. My forward correction and aft correction, which I'll be doing as normal. Okay. Once I get my forward and aft correction, I know since it's by stern, I will add the aft and subtract the forward correction. So my initial final even keel draft is this. Which I got it from here. I apply the corrections and I get the final drafts to be this. Okay. So understood on this problem?
Yes, sir.
Fine. So if you want to know, maybe once you practice it again, you will come to know slowly the difference, how it is being slowly improved. Or slowly we have added the difficulties. So initially direct displacement and LCG was given to you. So you were very easily able to calculate the moments table, find the final displacements and LCG and went on with the trim. Then slowly we gave you an even keel draft and shifting of weights. So now what we have done, instead of giving you directly the initial displacement and LCG, initial drafts was given to you. So from the initial drafts, you have to find the initial condition. All parameters have to be found out. So once you got an initial condition, then you know that certain operations is being carried out. With that, I will get my final condition. Okay, so after this stage, it comes back to the previous problems as how we did it. Okay, so any doubts, guys? Any doubts in this, whatever we have discussed, these three problems?
No, sir.
Fine, you're able to follow it, right? I'm not going very fast or
No, sir. Able to follow.
okay, fine. So